Good.
Okay, 3, 2, 1, and go.
Thank you, and welcome everybody to another fantastic LIDNUG and Wintellect series event. Before I go any further, I just want to make a brief announcement. LIDNUG, this week here we reached 50,000 members. We have now passed 50,000. That is a huge feat for a .NET user group, and we are extremely proud to have had you guys support us for the last couple of years. We have also been locating the 50,000th member, and Invar Gatsit, our founder, will be contacting him, and as soon as he has responded, we will have a few goodies for him. Anyways, back to tonight's topic. Tonight we have John Robbins. He's a co-founder of Wintellect, and this is the second time John has been on board. John is going to be doing .NET performance tuning. Everybody's seeing quite a lot of technical content today, so pay attention and don't fall asleep. And I want to thank our sponsors. As usual, we could not do all of these events here without support from our sponsors, Orgsweb, Telerik, Pluralsight, and especially for the LIDNUG and Wintellect series, we have Syncfusion, who has been doing a fantastic job promoting our events over the last couple of months. So thanks to all of those companies for their ongoing support. Upcoming events in November, we have Mitch Harpur. This is possibly the last LIDNUG and Wintellect event. We're looking to get another one scheduled, but for 2012 it may be the last one, and he's coming on November 8th. There's practical patterns with JavaScript, MVC4 and HTML5. November 15th, we have John Papa back again. He's going to be doing building SPAs, and from the feedback we've had from Pluralsight regarding his training course that's just been released on SPA, it's an extremely popular course. So stay tuned, and don't forget that go to LIDNUG events.eventbrite.com to see more information about our upcoming events. Of course, as usual, the LIDNUG and Wintellect series, we have Wintellect offering a visual training course valued at $499, and the winner has to, of course, have been present and registered, and he'll be announced today during the session. Syncfusion also has their tech portal open with both their Metro Studio 2 and all of their ebooks that they have been releasing lately. So go over to syncfusion.com/techportal and have a look at some of the things available to you there. Housekeeping, bit.ly.com or bit.ly/LIDNUG, I should say, is LIDNUG's home. LIDNUG.org is our unofficial website. The website is undergoing some changes lately, and we will soon be releasing a new, more modern site. Also subscribe to our calendars. Our RSS feed calendar is bit.ly/LIDNUG_RSS. Catch us on Twitter and Facebook /LIDNUG. If you have any questions to us, feel free to email us at info@lidnug.org, and we will get back to you with anything you may have questions about. And as I said before, LIDNUGevents.eventbrite.com is where you can find all of our upcoming events. So I'm going to hand over to John Robbins. John, welcome, and thank you very much for coming back again. Last time you were on board, it was quite a hit, and you've had repeated requests to get you back since. So thank you very much.
Well, thank you very much, Brian and Peter. I appreciate you guys inviting us back, and I have to congratulate you on 50,000 users. My God, that's incredible. And it's been a lot of fun because here at Wintellect, we've been very happy to have participated with some of these presentations. You know, some of you probably saw heard Jeff Procyse and Jeremy Lickness. You've got Mitch Harper coming up. So we've enjoyed very much working with LIDNUG, and you guys hitting 50,000 is just incredible. But let's talk performance here. So what we're going to do here is we're going to switch over to my desktop, and we're going to do everything as demos today. I got a couple odds and ends that we're going to talk about here, but we're going to get into the demos. But you know, we've got to talk about some things up front about this. First off, I want to mention that if you have any questions after this session or during the session, go ahead and ask them in the QA manager. But questions after the session, you can email me at john@wintellect.com. And if you are on Twitter, you can follow me at @JohnWintellect, and you'll get the benefit of my 140 characters of wisdom. And I'd love to hear your 140 characters of wisdom. So that's how you can get in touch with me, and I'll put those up after the session's done here. So as you saw from the introduction, I'm from Wintellect, and we're a big consulting company. We have been known as a training company, but most of our business is consulting. And you know what we're going to talk about here today is kind of what we do in the real world. You know, I head up the debugging practice at Wintellect, where we go in and debug and performance tune. And like one of the previous sessions I did for LIDNUG, we talked about WinDebug and SOS. This time we're going to talk about performance. But you know, this is all based in reality. In fact, we're going to do a live debugging challenge or performance tuning challenge based on real live code. So I do want to remind you, we do have some upcoming events with virtuals, what we call virtuals, which are very much like this, but they're more in depth. I've got one, a big one coming up on performance, but you can always look for our events at bit.ly/Wintellect events, and you can see my .NET performance tuning virtuals coming up in November. We also have Chris Love doing a big road show here, and so you can learn about Windows 8 to iPhone and back, and you know all of this kind of stuff with DX Extreme and Dev Express, which is a pretty cool product if you haven't taken a look at it. Just to remind you, as Brian mentioned, that you know we're going to do a drawing for the course coming up here, Wintellect Virtual course, the performance course, and I want to give a shout out to Syncfusion for sponsoring all of this between LIDNUG and Wintellect. So you know, make sure you go check out Syncfusion /Tech Portal because that's where they've got a lot of good stuff for e-books and white papers and things like that. So let's go look at some code. Well, first, let's talk about performance, right? And, you know, the thing when it comes, what we're going to concentrate on here for the next hour is .NET performance, okay? Because that's where the action is. And, you know, so that's what we're going to concentrate on. We're not going to spend our time talking about database performance or ASP.NET or IIS performance. We're going to concentrate on the .NET stuff here, right? The stuff that you and I control because we're the ones writing that code. Now, obviously, we control database performance and IIS performance and router performance and things like that. But, you know, many of the performance problems come out of code, right? The stuff you and I are typing into that wonderful editor in Visual Studio. But as a .NET developer, okay, let's step back for a minute, and there are three things that you care about more than anything else as a .NET developer, okay? And the first one of these things is the all-important memory, okay? This is what you care about, right? You know, .NET is supposed to be awesome because you don't have to worry about memory, right? Well, great. You don't have to worry about it. But what's the number one thing you worry about in production? It's memory, right? Because it all comes down to what is your application doing with memory and how much is going on with the garbage collector, okay? And so, you know, having an idea of what's going on with your memory is a very, very good thing. So let me check if there's a question here. Having some audio problems there. Brian will take care of those. The other thing is, so we've got our memory, right? What's the second most important thing you worry about as a .NET developer? Well, let me write that one down here, because right after memory, you care about memory. Are you starting to see the pattern here? What do you think the third most important thing is? Well, it's memory as well. All the .NET performance problems that we work on at Wintellect come down to .NET memory usage. Okay? Let that sink in for a minute. This is big. Because if you understand this, you're going to understand at least the first hurdle of doing performance tuning when it comes to .NET. None of the performance problems we've been pulled in on have been algorithmic, right? You know, CPU bound or anything like that. All the memory problems come down, all the .NET performance problems come down to memory. It's memory, 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 and more memory. So, you know, you have to get an idea of what's going on with the application so you can see from the memory side, so you can find those performance problems. And that's what we're going to look at here in a second. So what we're going to do to look at this is, let me just check the questions here. Okay, people, oops, there's a question there. This is a good question, John. Is it memory in general garbage collection? It's both, okay? It's really focused around the memory usage in the garbage collection. That's a good 85% of it. But remember, you've also got other types of memory there in the sense that you have you know, if you're using native code, right? Because where these memory problems come in is that you're using too much memory, right? Your memory, you know, in these big production servers, your memory goes up and up and up and up and up, and that causes page faults, right? And at the end of the day, a page fault ruins your day. So the one thing we can control best as .NET developers is obviously the garbage collecting memory. But we also care about the other types of memory. But it's really the garbage collected one is where 85% of your problems come from. And, you know, that whole idea of that page fault is death, right? Because a page fault is a very, very expensive thing, okay? And what is a page fault? A page fault is when the CPU is executing along and it needs to access a piece of memory that is not on the CPU cache, right? It's not, you know, it's not directly referenced by the CPU. So there's various types of page faults, but the main ones are the soft page fault where you have to pull that memory from RAM, right? The sticks, you know, the DRAM sticks you stick in the server. But you also have hard page faults, and those are page faults that you've got to pull the memory off disk because the virtual machine has swapped it out, right? If these concepts of soft page fault, hard page fault, and virtual memory are not making a lot of sense to you, let me mention a book here that will help you out. And the book here is called Windows Internals by Rusinovich, Solomon, and Ionescu. This is the book that kind of talks about the architecture of Windows and give you a pretty good idea. But this whole idea here is that page faults, bringing memory onto the CPU is amazingly expensive. Amazingly expensive. Right now, one thing that I found kind of interesting was years ago I calculated something up when I was trying to get my head around the cost of a page fault. And I did this calculation many years ago. It's a little slower now, or a little much faster now. But the idea was this, right? It said a CPU memory access, okay, was 7 nanoseconds. I think I was using a 400 megahertz Pentium 2, right? You know, whatever. That's the last Intel manuals I ever got. So, you know, I don't understand what a nanosecond is, okay? And they also told me the clock cycles. Well, I don't understand what a clock cycle is, right? You know, you might remember that a nanosecond is a billionth of a second, but, you know, that's a unit that doesn't make any sense. So I wanted to scale this up, right? I wanted to understand the cost of a page fault, okay? And so what I did is I said, well, I don't understand that, so let's do this. If a CPU memory access, let's scale that up to 1 second. I understand a second. That's cool. I can look at my watch and see that. Well, this 400 megahertz Pentium 2, when I was doing this calculation, I said, okay, well, I read through the documentation, and then we have the soft page fault. Okay. How long does that take? Okay. Because if it takes 1 second for the CPU access, how long does it take for that soft page fault where we read it out of memory? So remember, I'm just scaling up from nanoseconds here. This will surprise you. That's kind of a time difference, isn't it? Okay. And what's that hard page fault? Where we're going to read out of memory? Read it off the hard disk? 46 to 50 days. A page fault can ruin your day. Okay? So the less memory you use, the better off you are. And it's so hard to kind of get that idea very quickly what's going on. But this gives you an idea. Now, these numbers here, are like I said, were for a 400 megahertz Pentium 2. Which is an ancient CPU, okay? I just haven't bothered to calculate it since. But, I would imagine that, a soft page fault is now, in the order of an hour. But a hard page fault, right, because we all are using SSDs, right, that's probably, 6 hours. So, they've become much, much faster. Do you guys understand that when you have I/O problems, right, input-output problems, disk problems, do you know what the fastest performance tuning you could do is? Put an SSD on that server. That will solve many, many problems without you having to touch anything. SSDs are one of the greatest inventions ever. Many of you have done that where you put an SSD in a development machine. It's like, oh my God, it's like buying a new machine. So, anything you can do to avoid that swap to a physical disk, go get an SSD. It's going to make all the difference. So, this idea of observing memory is the key. So let's go take a look at an issue here. So I'm using an older version of some code I wrote that's an open source project, and you can get all of these open source projects that we've got here at Wintellect at code.wintellect.com. And that'll get you to our GitHub page with all of our projects. And the project I'm going to use here is an older build of a tool called Paraffin. Okay? And Paraffin is, as you can see there, it's to make Windows Installer XML easier to use. And the idea was this. With Windows Installer XML, you build up XML files that describe your installation. And if you're not familiar with writing Windows installers, it's kind of a pain in the neck, right? Thanks, Microsoft. But you have all used installers based off Wix because everything at Microsoft is produced with this. Windows Installer XML is Microsoft's open source tool for building installers. And it's a pretty good tool if you've got to install big things. I've written installers that, with the new Burn engine and stuff, 1.9 gigs, right? Installing 17 websites, 47 services. It's very scalable, very strong. But one of the problems you have with Windows Installer XML is you need to install a bunch of files. So the idea is that you have to sit down and write in fact, let me show you what this looks like. You have to go write a handwritten file that dumps out this XML that needs custom stuff on it. So I'm going to run this just so you can get an idea of what it looks like. And this is going to form the basis of our work. 1, 2, 3, 4. All of this stuff in. Okay. And I'm just going to run this outside the IDE, and it's running. And what does this produce? So Wix is a pretty cool thing, but if we go look at our release directory here, what I produced was this gigantic XML file, okay? And this XML file is kind of cool. And if we kind of roll through here, it's just a big XML file. You see, this is all Paraffin does. So what Paraffin is it's a tool. Wow, it's over 10 megs. That's kind of funny. But what Paraffin does is it helps automate the process of building this particular XML file that can then be used in your installer. So all Paraffin does is enumerate the file directories and build this file for you. So it's a lot of XML manipulation. But it turns out, Paraffin's been pretty popular. I'm very, very thrilled that a lot of people have felt that Paraffin is useful, right? You can go get it there at code@wintellect.com. So let's do some performance tuning on this. Now, the version that's up at code@wintellect.com on GitHub, that's all fixed up, okay? We're going to look at an older version of this that's got these problems fixed. Okay? Yes, Anderson, the recording is available at the LIDNUG website. after the session. Okay. So let's go take a look at this performance tuning. And what we're going to use here is I'm going to use Visual Studio's performance tools. Its profilers are very, very good. And this will give us an idea of how to go in and dig with these tools. And since these are in premium above, almost everybody has these. And they're very, very good tools for your day-to-day stuff. We also have commercial tools. The Redgate tools are very good. The SciTech.net Memory Profiler is very good. So, any of these tools can help us look at memory. But let's go do some real-world performance tuning. Okay? So here's what we're going to do. I can do all of this at the command line, but we can use the IDE. And this is one of the nice things is that we can make this very easy. So we're going to analyze this with the wizard. We're going to launch the wizard and go do some work here. And let's talk about the types of analysis that can be done with the tool here. By default, we're going to do sampling profiling. Right? We'll just do this initial run, and that's for algorithmic, just to get an idea of where things sit. Then we can move to instrumentation, and we can also do memory profiling with this. But let's just take a look at basic runs here. And I do want to mention that the Visual Studio profilers can profile anything: ASP.NET applications, JavaScript, services, WPF. Right? They handle everything you could want. This just happens to be a simple console app, so it kind of makes it easy to do. So I'm not gonna run here, because like with any performance tuning, what we want to do is that we want to get to a point where we're going to do some common analysis. And so what I'm going to do here is I'm going to get the cache all warmed up by running it 3 times. Right? So I'm concentrating. I'm not going to have page faults in the middle of this, because I want to look at my code. So that's why I'm going to run this 3 times here. And there we ran. Now let's go ahead and run this. Oops. Click the actions. We'll start with profiling. And we'll let this run, and it's going to load a kernel mode driver for us here. Oops. And that went over to session 0. But, we loaded a kernel driver, and it generated the run there. And let me get the question as this is going. Yeah, I'm using Visual Studio 2012 here. Everything I do is almost 110% identical between Visual Studio 2008, 2010, and 2012. They haven't changed much of the work of the profiler. They've tweaked some UI things, but the core functionality is all the same. Okay, so just using the standard stuff. So this is kind of cool. Okay. And, I'm going to make that big so we can see it. And we get to see, our sampling time. There's total time and our CPU utilization. But we get to see some good stuff down here. We get to see the hot path. And this is the key thing that you care about when it comes to performance tuning. And, we're doing sampling profiling here, right? And sampling profiling is pretty cool because it's a device driver that basically X number of units, and by default it's every million clock cycles, it reaches out and says, what is your program doing? What is your program doing? What is your program doing? So sampling profiling is very, very good from a very high level, right? I just want to run my application and kind of find some basic hotspots. Some of the stuff that gets a little bad with sampling profiling is, well, wait a minute, sampling profilers, they're sampling whatever is executing on my threads. Well, a lot of my code does not execute, right? Because I'm calling something in the framework class library, which can call something in the operating system. So one of the problems with sampling profiling is that you don't get to see your code all the time. That's general sampling profiling problems. But the Visual Studio tool has a bunch of magic pixie dust with it. And one of the things that it has is that it has the ability to suck off the call stack very, very quickly, very low overhead. And so we can get some very good stuff down into our code. And that's what the code will tell us here in this hot path. And just to give, so this is kind of the basic run, and it's kind of showing you the functions that had the most work as well, which means the exclusive samples means it was executing when the code was running, okay, when the sample was taken. So basically we're seeing 20% of the time it's something to get files, right? Since this is a file enumeration thing, that would make a lot of sense. But here's the big trick with Visual Studio Tools. The really big trick is this. The call tree view is where you spend all your time. And let me get mine set, because I turned this off. And the default, this is what you would have out of the box, is this thing called noise reduction. And the noise reduction is here. The idea is good. The implementation you want to turn off. The idea is this. They're like, okay, we've done the sample run. We want to trim out all of the small stuff so that we're concentrating on the bigger things, right? So the intent is good. But in the real world, your stuff is all the small stuff. Your code is all small compared to something like get internal files. So the trick to use the Visual Studio Performance tools is to turn off the noise reduction, right? So you want to configure this, you want to turn it off. Because the issue is, with the noise reduction, a lot of your code doesn't show up. So you just see some of the bigger stuff, not your stuff. Now let's talk about inclusive versus exclusive before we do the big super trick here. Exclusive means it was executing when a sample was taken. So it says, so if you've got a big algorithmic problem, you're looking for exclusive. Say you're working on video processing. You care about exclusive. How much is my stuff processing while it's running? Now, inclusive, on the other hand, this is what you care about as a .NET developer because you care about your usage. And inclusive means it is in the call stack when a sample was taken. Okay? So exclusive is at the top of the stack, currently executing. Inclusive means it led up to that thing that's currently executing. Okay? So here's the big trick with the Visual Studio tools. See this awesome flame button? And you know how we all love how Visual Studio 2012 has no color? This is a place where they really need color. That flame button right there really needs to be red because this is the big trick. Are you ready? Do you want to see how hard it is to find your performance problems? You click that button. That's it. You're done. That's all you have to do. Because the key to performance tuning is figuring out where you've had the performance problems. And what we're looking for here is inclusive samples. So what this does is the flame button basically does an auto-analysis and says, here's the call path that had the biggest problem. And that's what we saw in the summary view. So what we can do here is that we can look and be careful because they'll sometimes show two like they've done here, but we can see that there's more of this recurse directories for new files showing up. Well, let's just go dig into that. We can flame some more, and you just keep flaming down until you find the problem. But look closely at this tree here. Do you see what the issue is? We've got a big recursive program, okay? So it's going to get a little hard for us to pull out where the issues are with this kind of recursive program. And, but I wanted to just show you the basic usage of the profiler here before we dug into memory. So that algorithm we just followed, run it under the profiler, turn off noise reduction, flame, 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 is what you're going to do for all your memory problems because that's really what we care about. So let's dig into this, okay? And what we're going to do here is I'm going to turn on the memory tracking, okay? And we've got, we can change our work here. And the first is, do we want to do sampling or instrumentation, okay? Sampling, I explained, goes out and catches, every million clock cycles what's executing. And the drawback is that, it's not good for smaller things and sometimes loses the call stack, though the Visual Studio tool does not. Instrumentation gives you perfect call stacks, and it is very, very good for small things. The drawback with instrumentation is that you're going to have to change the binary, and you're going to have to, it's going to have it's going to run much slower in the big scheme of things. So let's just turn on instrumentation, and let's go start collecting memory, okay? And basically what I'm doing here is that exactly what I do when somebody says, I've got a performance problem. First thing I do, let's just instrument this thing and go collect memory, okay? So that's a good thing. That's the basic algorithm, basic pattern here. Go turn on instrumentation. Let's go look at my code. We could do sampling with the memory profiler, and that works fine, but we have at that. But the difference between instrumentation and sampling when it comes to memory collection is that sampling has a tendency, that shows you more about what's going on in the framework class library and third-party components, not directly related to your code. So you go a little bit, you go much, much deeper, but really what do you care about? I just want to know my code that is in turn allocating a bunch of stuff. So I've always found it best to use instrumentation with memory profiling to kind of, I want to narrow it down to my code, right? Because that's the stuff I can control much better. Another thing we can do with instrumentation here is by default they exclude small functions. Let's turn this on. This is a relatively simple program, so this way we can kind of get everything that's going on. So there we go. We've got everything ready to go. I'll close this run down here. And let's get our run done here. We're going to run it 3 times to get everything going. Right? Because we want all the caches warmed up. We don't want anything like that. And now we will start profiling. Okay? So this is going to run a little bit and gyrate. And you can see it's taking a lot longer to run. The sampling run that we did before was, what, about 4.5, 5 seconds? You can see this one takes a little bit longer, right, because there's more overhead, because every time that you go into a function and allocate memory, they're recording that information. So there's just more overhead involved with the instrumentation. Okay? And the good news about the instrumentation is that you can narrow it down at the command line to only do one binary. I just happen to be doing everything here. So great, you can see that it took, almost twice as long, right, 12 seconds to run the whole thing. But now that we're looking at memory, because that's what we care about, we can kind of see very quickly the functions allocating the most memory, right, what percentages, wonderful piece of information. And notice it's kind of the same as we saw, right? So this get files, which is that method that's going to pull out the files off the disk, well, guess what? We saw that in the general sampling, okay? So that's kind of, makes sense. But we also get some other data down here, types with the most allocated memory and the types with the most instances. And this is a program that produces an XML file. So does this make sense to you? Well, yeah, right? Looking at I would expect strings to be a big chunk of this. Now, if you see one of your types at the top, that's kind of a big red flag that that's not a good thing. Okay? So let's go dig into this. Let's see if we can do anything to improve performance. Step number 1, what do? Call tree. Okay? We care about inclusive bytes. Okay? Let me explain again. Inclusive bytes versus exclusive bytes. Exclusive bytes means this method allocated a piece of memory directly. Okay? So that's how many it's responsible for when it did a new. Inclusive means it was in the call path allocating memory. Okay? It's kind of an important distinction. So we care about inclusive bytes. That's the fun stuff. So what are we going to do? Right there, just to sort that, we're going to hot path this out, and what are we going to do? Okay, it's telling us here very easily that this recurse directories for new files, right? We can see that it was broken up inclusively. It's what, about 255, almost 256 million bytes, but big chunks of that were done by these two. Okay, this add files to new directory node. That was one that was taking up a lot of space, right? That used a lot of memory. So let's dig into this a little bit more. How do we do that? Flame. Okay. And so, this is kind of neat because we're just flaming down and drilling into that hot path. Okay. So this is kind of interesting. So we see that that's responsible for, what, about 106 million bytes, but 36 million of it or so comes directly from get files. Right? Now, there's not a whole lot I can do with that, but because I have to get the files off the disk. I guess I could go rewrite get files, but that's not really my code. So let's take a look at this create component element. This is something I can control a little bit better, and we can see that inside create component element, it had a million bytes that it allocated, but notice it had 38 million bytes that it was responsible for allocating by its calls. So what are we going to do? Flame on, baby. And we get to see one level down. Very, very interesting. We get to see here that the create 70 char ID string is responsible for 22 million bytes, and it was responsible for 1.6 million of the exclusive bytes. But here's the calls that caused the issue. So I'm just going to go after the low-hanging fruit here. Here's the big one: remove invalid ID chars. That's 8 million bytes versus 6 million. Let's go see if we can see what that is. Okay? It's telling us it's a regular expression. Well, let's go right here and go look at the source. So what does this do? Okay. So this is telling us, look at that source code. This is remove, it removes some invalid characters from a string that Wix does not support. But let's look at what got allocated there, right? Look closely. See, there's the remove invalid characters, but you see it's a bunch of 8 million bytes of allocations based on that guy right there. Well, do you see any allocations here? No. Well, let's go look at the redgate tool, our favorite tool of all, the teller of all truth, reflector. Let's do a search. Get our regex class here. And there's our regex class, and we want to go look at which one did I use? Regex.replace string, string, string. That's the one I used, okay? Regex.replace, regex, compile. Oh, we can do Control F down here. Okay. So we did the regex.replace string, string, string. There it is. Let's go look at that method. Oh, okay. So that method replace calls another method replace. Oh, okay. Well, that kind of makes sense. Now we see why we've allocated so much memory, okay, in that path. What were we responsible for here? We were responsible because of this nice little static call here. What did we do? We created 8 million bytes. Okay. Do we really need to do that? Probably not. So how could we fix this? Okay. How could we fix this code? Let's go back and look at this code. How about we do something like this? Okay. And we've got to do it's the 2-parameter version, right? Oh, the 1-parameter. So we got to pass in this guy. Okay. So does everybody see what we're getting ready to do? Type, I'd be dangerous. So what did we just figure out? Okay. We figured out that this method was allocating memory behind the scenes with that regex.replace that we didn't expect. Okay. So let's, hopefully this will make a difference. Okay. Let's rebuild our app. Okay. Run it 3 times, and how are we going to check the difference? Right. Well, let's go run it and go find out. So there's the first run. I'll get to the question here in a second. Okay. Let's get the run going. Okay. All right, so we can compare like to like. That's true, that this is not thread safe, but this is a single-threaded program. And so, I guess I should have mentioned that you're exactly right? This program's simple enough, but this could cause problems if this were a multi-threaded program, and I do appreciate you pulling that out, right? Because that's exactly right. It's not thread safe, but in this case it's fine because it's a single-threaded program. Okay, very good point. Okay. So great, we just did this run, and we can now look at our analysis, and we can kind of see here that get files was 24%. What was it before? Well, we can go back to our summary, and we can see it was get files was 21%. So we're seeing better. Then it was get directories, then string builder. Well, this is kind of hard, right? This is kind of ridiculous to compare two files manually. Okay? We want to see if we made a difference. So let me show you the real trick here with Visual Studio. In the Performance Explorer, control-click the two sessions you want to compare, then right-click and compare them. Okay? And what we care about is not exclusive bytes. The thing we care about is inclusive bytes or inclusive byte percentages or one of those that will talk about our allocations, right? So let's just look inclusive bytes completely. Here's the trick, okay? Notice I see a bunch of green arrows going down. What does that mean? The more green arrows going down you have, the more you've improved performance, right? I don't even really need to look at the numbers, but I have improved performance of this application. Okay. Okay. Yeah, I didn't want to get into all that, but that's some of the that's what you need to check with the classes. You need to check the documentation. But if say this was one of my objects, right? Ohad's exactly correct. If I didn't make this thread safe, I could cause some problems, right? But in this case, we're a single-threaded app, so it's a little easier to get away with. Okay. So appreciate the follow-up. So this is good, right? We improved performance. Right? And how long did it take us to do this? Now, I was talking through walking slow. The first time I ran this, we're talking about 2 minutes worth of work. Okay? But you're probably wondering, well, that's great. I saved some memory, but did I improve performance? Okay? Well, let's look. Right? It took about a little over 12 seconds before to do that run. What did we just do? Did I improve performance by changing the memory? Yes. Absolutely, emphatically, yes. So why did the performance improve? Well, let's go back to our first run. If you think about it, we were allocating 15% of the bytes we allocated were done by that regex.replace. By getting the system to avoid using that memory, by making it a static so we only allocated it once, what did we do? Not only did we reduce the overall memory usage of the application's processing a whole hell of a lot less, right? That's the big performance improvement that you're after when it comes to .NET code, okay? It's really tracking down where are you causing the garbage collector to do the work. And the less work the garbage collector does, the faster you're going to run. Right? So if you get that, you understand a big chunk of .NET memory performance tuning. So let's dig in some more, right? We've done our second run. Life is looking pretty good. So let's go look at this guy. Let's go see if there's anything else that we can look at to see if there's been hassles. Okay? Potentially, Ohad, it's one of these things that in 99% of the cases, the instrumented, if you see a performance boost from the instrumented version, that's going to apply overall. But yes, to follow on, you're exactly right. We do need to go do some bigger runs, get some more data. But I just wanted to show you in a small demo form here that the fact that without doing, what turned out to be, what was the number of percentage of bytes here, right? We got rid of 3% of the allocations, okay? And just that work alone, right? If you read CLR via C#, okay, let's get to another book here. CLR via C# by my friend and business partner Jeffrey Richter. Oh, hey, it's by nobody. That's kind of funny. I have to tell Jeffrey about that. But the less work a garbage collector does, the better off. But yes, we're not done with performance tuning here. But the big thing I want you to realize is that a lot of the performance tuning is just knocking out just 3 or 4 of the low-hanging fruits. If you knock those out, now you've got some big changes that you can really tell. So this one run here isn't going to improve performance. We're going to have to do multiple runs, okay? So let's dig into this a little more and see if there's anything else that comes to the forefront that we may be able to improve the performance on. So let's make sure we're looking at the latest run, okay? And how are we going to do that? Same thing we did before. You go to the call tree, flame on, baby, right? That's what you care about. That's the easy thing to do. So there's our run. We see the recurse directories, add new files to directory node. We can flame in on that. We have the get files. There's not a lot we can do there. The create component elements doing a big chunk as well. That's just what we saw before, so it's kind of pointing us to the same area. And we see the create 70char ID string is there, but we also see this is in create component element. So we see that we can expand that, and we saw that the create 70char ID string, oops, I'm in the wrong method, sorry. So let's go look at this. This is the create 70char ID string. Let's go look at this source code. Okay. So what it is that Windows $XML requires that the identifier be less than 70 characters. So that's what this guy is for. That's what this method does. Just make sure it's over, under a specific amount. So we've got the create 70char ID strings here. Let's flame on that. And what is it telling us? Okay. So we've got our create 70char ID string, and who's causing the most memory allocations? Hey, we've got a string builder right there. That's the top of the list, right? That's almost 7 million bytes are being created. So let's go back and look at this source code for a minute. And because we're allocating this local variable, but this is getting called so many times that we're causing, more memory to be allocated. So let's do something neat here. Very much, what we did before. Here's my refactor. Now it's just lost my refactor here. So let's just change that. A different name. Okay. So what can we do to produce less work here? Well, very much like what we did before. Okay. So I got to do a little difference here, because I want to make sure this is reset to 0 so we don't change anything. So what are we going to do? We're going to make that static. Okay. This is not the answer to all of the problems, but this is a real-world problem. Okay. In fact, I could probably make that an instance variable and be done with it. Okay. So just make that a field. Okay. So this way, because we're just this is gonna be one per instance, right? Hopefully this will solve this problem because we're doing less work inside here. Okay. Oh, that's a static, so I gotta make this a static. Okay. So that happens to be a static method, so we'll just make this a static. Sorry about that. Okay. So now things will be a lot better. Okay. So let's see if this improves performance any. Okay. So there we go. Let's do our 3 runs again. So we're back to the same spot. Okay. And you guys thought this was going to be hard. It really is. The thing I want you to take away from this, it's much, much easier than you think. Because, when we've gone in to do these performance tuning scenarios, the big thing is just find 3 or 4 of those initial problems. And if, because a lot of times when you look at performance problems, it's like, well, wait a minute, we're going to have to re-architect this. Well, crap, that's going to be 6 weeks, 6 months worth of work. We can't get away with that. Well, if you can tweak, a 10% performance boost in about an hour, that may be enough, right? So that's how I want you to think about this, to go back to the office and say, you're in your office, go back and say, well, what can I do to improve my performance? Just go run the profiler a couple times and get a handle on your memory usage. So this is kind of cool. Okay, so what we did is, and now look at the performance time that we're talking about here. Now we're less than 11 seconds. What was the original run? Right? That was over 12, right? We lopped off 2 seconds on my run. So what is this? We had what's 2? We lopped off 1/6 of the performance, and if you go back to the office and do the same thing, we're probably talking maybe 15 minutes worth of work. Okay, so that's a pretty good return on your time. So just figuring out where those 2 spots were We just reduced our work. And what I wanted to show with this demo was just that effort in what it takes to go find performance problems. That it turns out in a lot of these cases is that you're using more memory than you ever expected. And if there's ways you can just shrink it a little bit, the multiplier effect is gigantic. So this is pretty cool. So let's go and just to show you the performance difference here, there's our original run, here's our subsequent run. Now let's compare those performance reports, and we just care about inclusive bytes, that's all that matters here. And well, you're going to see some big numbers here, right? You know, we're talking down in the overall main, right? We reduced, you know, by 50 million bytes, right? And so that means there's no Gen 0 collections there. So our application runs faster. Okay. I believe it is there. It's It is in Pro, I think it is, and it's off the Analyze menu is where you can find it. You can see more in the docs about how to get at it. So this is, you know, I hope I was able to show you, you know, it's not that hard, okay? And, you know, the more green arrows you have here, the more you've improved performance. So this is one of those things that, you know, I want you to go back and realize that it's not that big of a deal. And all I've really touched here is about 5 to 10% of the Visual Studio performance tools. But you know, this integration with the premium edition and higher in the Analyze menu is everything. And this makes it very easy. And since it can easily run and view all of this good stuff, right, you should be running this a couple of times a week, okay? Where do you get the total memory performance gain, Daniel? It's a good question. Really, what I did on the comparison view here is I looked for the highest level method, okay, which this being a console application being main, there's the change that I reduced it by 51 million bytes. And so this way you can say, yes, we improved the memory usage. We're allocating almost 51 million bytes less, right? Which means fewer garbage collections, which means also that the Gen 0 promotions maybe aren't occurring. So it's a multiplier effect of all of that work, okay? Pranav, there is a way to run this with the build automatically. If you are using TFS, you can turn on, with TFS build, you can turn on performance runs very easily as part of the build. You know, just go read up on the documentation for TFS builds. There's ways to turn performance tuning on. Also, you do not need to have Visual Studio on the machine, because you know, the overall here is that, you know, we're just running this day-to-day work, but if you have, in fact, we can go to a website, BS 2012. Okay. You can download the remote tools here from Microsoft, and what these tools will give you is the ability to do all of this at the command line. Obviously, we don't have the time to go in this session to go through that, but everything I've done here from the UI, you can do at the command line. It's relatively easy. The documentation is really good. All you need to do is vsperf cmd. I've done a lot of work with this command line tool, and this is the command line tool that will get you started with the stuff on the command line. So you don't even have to have Visual Studio on the machine. Okay. Okay. So great questions, guys. Oops. Let me get through these questions here. David, you're absolutely right. We did have memory go up. Okay. So what we're seeing here, it's a very good point, is the regex.replace, remember that call I removed, the baseline, there were 0 allocations, but we allocated 13 million bytes for that method that we hadn't before. That's why it's kind of showing you. And we also see the effect of putting the stuff in the program's constructor and the regex constructor that get called. See, those were pretty low before, but those boosted up because I was allocating that regex. But my overall inclusive delta was 50 million bytes. So, you know, yeah, this is not we still had to allocate more because of the regex.replace, but by avoiding allocating a regex object over and over and over, that's where we got the big savings. Okay, so that's a great question and a great point. Okay. Jessica, this is another great question, and when it comes to performance tuning, there's two ways to look at it, right? You've got like macro level and micro level. Okay, macro level or micro level is the one everybody thinks about. Like, I'm going to call this method 100,000 times. Right? So you call the WCF services. You call each method. You just bang on it really hard. That's a very good thing to do. That helps you isolate down some of the smaller stuff. But that can lead to false performance tuning, because you get focused on the minutia and not the big picture, and that's where the macro comes into play. So I think you kind of do these both, but what I like to do is sit down and figure out what is the most common usage through the system. Okay, my case for the Paraffin example was simple. I just need to run it against a directory and see. But when it comes to like a website or WCF services, what is the most common usage pattern through it? Now, that can lead to a lot of fights on the team, because what you think is common is not what somebody else thinks is common. But you're going to have to decide what's the most common usage scenario, and then start testing that so that you can see kind of that overall, right? Because if you test just this WCF method, then just that WCF method, sometimes you have these relationships between them that don't get tested. So, you want to do both levels of testing. During your day-to-day development, you're probably going to want to do the micro stuff, but at least weekly, do the overall stuff to see if anything falls out. Okay? Ritesh, no, there's absolutely no difference whatsoever. Right? You can attach to any ASP.NET host that you want to, whether it's IIS Express or IIX. So what? You're just collecting data as they run. Now, if you're doing the issue where you want a duplicatable, right, then you probably want to go to load testing so you get a duplicatable run so you can do real comparisons, right? I've seen folks try to do try to do performance testing, and when they have like a quick beta release and things, that's fine, but how are you going to compare apples to apples? So it's generally best to sit down and say, okay, let's set up a load test so that we can bang this the same way each time. And then that way we can get apples to apples comparisons. So yeah, you're going to test it the same way, but it's how you're going to drive the test. Okay. Hey, I know Andy Hopper, smiling bald guy. It's good to talk to you again, Andy. Yeah, it would be because another thing that you might want to do also, Andy, is not only with the ismatch, also take a look at compiling the regex, right? And there's other things that we can do there along those lines, and I think it would be really interesting. Now, this is a simple, small enough program, but Andy's bringing up a good point. If you're doing a lot of regexes, there are many, many knobs to turn, right? Shortcut that call to replace with ismatch. Do the compile. Check to see if setting the options to make it compiled. Right, that might slow down your startup. But if it's a long running WCF service, that startup cost may be saved by orders of magnitude because you've compiled the regex to IL. So yeah, there's a lot of things when it comes to regexes you can play until you're sick. Okay. Oops. Yeah, Anand, I'm not sure which versions the profiler is in, but take a look and talk to your boss about getting a new version. Okay. No, this is a good question. Out of the box, in like say TFS build, I don't think they have a knob that allows you to say, if the performance run takes longer than X, do it. I think what you're going to have to do, I'm most familiar with TFS build, so I'll talk from that regards. What you're going to have to do is from the command line, you're going to have to do a lot of this from the command line. There's very good VS Perf. report. This VS-perf report command line tool can dump out the raw data from the VSP files into a text format. So what you would have to do is that you would probably have to have some task that would dump the data out and then kind of munge it and then do your comparison. But in fact, this question here, and I'm gonna put the pressure on you, Noam. I want you to go write a blog entry that shows people how to do this, because that would be a very, very good thing to know. The idea is you would have to pull the data out and do it manually. There's nothing built into TFS in particular that have that support with it. Okay, so it would take some coding, but it is doable. Okay. Kevin, good question. Okay, the Windows Performance Toolkit is compare and contrast. It's far too low level for .NET development. Okay, the Windows Performance Toolkit is a really, really interesting system that allows us to do. It's written by Microsoft to tune key parts of the operating system and applications that are written to produce ETW data. And so the Windows Performance Toolkit is, in the big scheme of things, too low level for most .NET developers, because it's down to, and plus, like the call stacks it shows doesn't show any .NET stuff, those kind of issues. If you're dealing with machine-wide performance, where you're wondering, well, is my bottleneck coming from my application? Is it the disk? Is it the wire? WPT is awesome, because that's the tool that's going to tell you that information. Interestingly enough, the Visual Studio Performance tools, I'm running Windows 7 here, they do not use ETW for the sampling or instrumentation. If you happen to do concurrency profiling, okay, which is another type of instrumentation that can be done, the concurrency profiler, that will use ETW, and the Visual Studio tools become the Visual Studio UI becomes an ETW reader. So this is very, very good for algorithmic and situations where you're looking where you suspect that blocking is the problem on high volume multi-threaded applications. That's where the concurrency profiler comes in, and that will use ETW. But the perf tools are a little heavy because they're just too low level, right? And they don't show you the .NET call stack. But it's a good thing to know about if you're looking at overall machine performance. Uh-oh. Good. I threw down the gauntlet on no. Okay. Suresh, you cannot dynamically load it. Now, if it's just loaded by an assembly.load, that means the assembly resides on disk. You can instrument that prior. So that would work. Sampling would obviously work. Now, if you're talking about getting performance of code that is built up through reflect.emit, guess what? That's not going to be instrumented. You can do sampling profiling on it, though. Okay? So that's the difference to make that happen. Great. Wow. It depends, right? So this whole session here was about the memory profiling. Where are things happening in your code? The easy to fix things, right? That's what I wanted you to take away from this session. Where it comes next is kind of overall performance, right? Once we realize, okay, look, we've taken care of all the dumb stuff. Now we got to start looking at database performance. Now we got to start looking at disk performance. So, when we go in and do these performance jobs, we try to box up all the simple .NET stuff and get that out of the way. Then we turn to some of the bigger things. Now, sometimes those scenarios, it's very obvious that the database is taking so much longer than the application, or the WCF service going through the web farm and the routers and things like that. Sometimes it's pretty obvious. But in the general case, it's look at your memory performance first, get rid of the stupid stuff, then you start looking at the other things. And so go look at the database and the wire and that kind of stuff. And how would everything change? Kevin? Not at all. I happen to do a console application here. The only difference with the WPF application is that you might want to sit down and use coded UI tests to drive the UI so that you get a consistent pattern of usage. And with the coded UI stuff, they drive WPF applications perfectly. So what you would do is that you would instrument the app, start the collection system from Visual Studio, then have the coded UI run against it to test. The coded UI stuff works with web apps too. So if it was a web app that you were dealing with, you just drive some browsers till you get consistent usage, right? Because we kind of want, why keep mentioning the consistency is that we want to get that apples to apples comparison. But sometimes you can just play with the app. Don't be afraid that you just sit there and do some things with it so that you find where some of those problems are. Okay? Inclusive versus exclusive. No problem, Tim. Let's look at the difference here. So, okay. So let's talk about exclusive. Okay, so we got different ways. Sampling. From sampling profiling, it was executing. Okay, so it's at the top of the stack. Okay, exclusive when it comes to memory is okay, so it did a new. Okay. Inclusive for sampling is in the call stack when sampled, and when it comes to memory, in the okay, it was in the call stack for the ultimate allocation. I should, okay. So if A calls B and B allocates a string, A is going to be inclusive to that string. Does that make sense? Okay. And so that's the idea. And why do we care about this inclusive so much, especially when it comes to memory? Because you're calling stuff in third-party libraries. You're calling stuff that's in the framework class library. It's your usage of those environments that are causing the problem. So you care about inclusive because that's going to get back to your code so you can fix it. All right, and that's what you're after. Okay. Yeah, Ritesh, yeah, you're right. But this session was on .NET memory, and .NET performance tuning, and the low-hanging fruit for .NET code is the memory. Yeah, it's database has its low-hanging fruit, dynamic versus stored procs, all of that. All environments have their low-hanging fruit, right? When it comes to, if you suspect it's a multi-threading problem, you're going to start looking at your algorithm going anywhere where I'm blocking, that's where the problem is. But when it comes to .NET, the low-hanging fruit is your memory usage. And, that's what I wanted to get across here. Database has its own thing, on the wire has its own thing, but it's all that kind of, who's doing what to whom is where the issues are. Okay? Cool. How much more time do we have, Brian?
You've got another 20 minutes.
Oh, excellent. Good. I want to make sure that we got the all those questions taken care of with the memory. Because what I want to turn to now is I want to turn to another type of memory analysis, and I just want to point out here, Visual Studio does do a fine job, okay, on memory tuning. Okay, you can look at allocations, you can look at the types allocated, but a lot of times I have to be honest, the memory profiling in Visual Studio isn't kind of showing you as much detail as possible. So when I'm doing my day-to-day development, what I like to do is get an idea of my memory usage. Overall, with Visual Studio is fine with that. But when I really want to drill into the memory usage, I turn to another tool. And there's multiple tools like this on the market. The first one, this is a commercial tool, is the ANTS Memory Profiler from Redgate. Absolutely fantastic tool. I've used this tool many, many times for all sorts of interesting memory usage, especially with day-to-day development, right? You know, and I use every single one of these. Where's my Redgate tools here? It's somewhere. Of course, it wouldn't come up in the search. But, you know, I use all of these tools all the time. You know, because they're good, right? So the Redgate tool is very, very good. Another commercial tool is the SciTech.net Memory Profiler. Okay, both these tools are competitors, but you can see right from the graphics that are shown on these tools, they're much more graphical, much easier to use to get some overall views. Okay, so you can see, especially with the SciTech tool, the graphic, that Redgate has a very similar graphic. So you know, when it comes to like really digging into like who's referencing what, who's doing what to whom, the Visual Studio tools kind of break down. And when I've got to really figure out where the memory issues are, I'm going to turn to one of these tools. So let's look at an interesting scenario. Okay. So I wrote a little Windows Forms program. Forgot the CD in front of that. Okay. I wrote two versions of it. I wrote the original version, and I wrote a animated. It's kind of backwards, but the animated algorithm display 2 is the original version. Don't ask me why this went. And animated algorithm is the fixed version. Okay. Yeah, the CLR profiler is fine. The CLR profiler is these commercial tools are a little easier to use. The CLR profiler works fine. It is free. Okay. And works fine. So, you know, but the commercial tools, I'll get into some specific stuff that they do a little bit easier. So, you know, it's worth spending the money on. Okay. Dot Trace, great tool. I just forgot to mention Dot Trace. You know, let's make sure they all get mentioned because I've used this as well. JetBrains Dot Trace. I just forgot to mention it. Thanks for bringing it up. All three of these tools are absolutely outstanding. They all do very, very similar things. You cannot go wrong with any of them. I have used all three of them to find massive performance problems, memory problems, right? All three are good. Highly recommended. Okay, so yeah, sorry, I forgot. You know, I always forget the poor JetBrains guys, even though everybody's using ReSharper. So let's get back and look at our code. So the original version here, if you look at it, is a little bit slower, right? It's 1.8 versus 1.6. And if we kept playing around here with animated algorithm 2, what you would find out is animated algorithm is on average 27% slower. Okay, so that's kind of not good. Okay, so since we only have 20 minutes left, I'm not going to take you through the Visual Studio tool with this. What I'm going to do is I'm going to use the .NET Memory Profiler here. And I just updated it this morning. That's why it's in my system. Okay. And these tools all integrate into the Visual Studio IDE. I'm just running it outside the IDE. And it can profile anything you could ever throw at. But I want to show you one of the power of why you want to use this tool and the Visual Studio Performance tools side by side. I use them all interchangeably. So we can profile anything we want here. Let's go do my animated algorithm 2. We can, you know, pick how much memory we want to, and the detailed presentation, medium is generally pretty good for almost everything you want, because that'll give us instance tracking and so on and so forth. The high when you're, you know, can get pretty crazy because that'll go down to heap utilization, everything else, but the memory's good enough. We can do per app domain. Those of you working with app domains will love this because the Visual Studio tools don't show you per app domain stuff. If you're dealing with a lot of native code, this will also look for native memory leaks. This is something unique to the .NET Memory Profiler itself. The other tools don't do that. And I do want to collect instance data. So this will let me collect, for each allocation, it'll let me collect the data. So I'm going to let this idle for a minute, just so we get, you know, just everything gets all started up and sitting there. So you can see some differences here that we're going to take a look at. And good, I'll answer a question. Well, Will, I pick all of them. All of them are very, very good. There is one thing that I recommend that at the end of the day is a godsend to me. It may not be for you, and it happens to be with the SciTech tool. If you spend the money on the Pro version, you can open up mini dumps. So when you have a memory problem on a production server, you can open up the mini dumps and look at its memory. And since that's a lot of the work I'm doing, this is incredibly important for me. Okay, but like in my day-to-day work, I kind of like the RedGate tool. Just get an idea of where my memory is. Keep an eye on the patterns. The RedGate tool is great. I use all of these tools interchangeably. I will, for full disclaimer, the RedGate folks were very nice. I had spent money in the past, but they gave me their latest version, to be fair. The .NET Memory Profiler tools, I purchased that one. The only contact I had with the company was, getting my credit card straightened out, and I have purchased the .trace. Okay, so I look at it this way. Your time is incredibly valuable, and I want to know how these tools work before I have to use them. So I've done the work with all of these tools, and really your time that it takes you to go find a memory problem. I sat on a plane. I sat next to the VP of a Fortune 20 company, and that VP was the VP of Human Resources. And you don't get to talk to those people very much. And I said, one of the problems that we have in our consulting business is I recommend tools, and the developers all say, well, my boss won't pay for it. And I said, from HR, what can you do to justify this kind of expenditure for $300 on a tool? And they said, the guy said, it's very easy. The cost to you, to the company, is 3 times your salary, right? So if you make $100,000 a year in the U.S., you actually cost the company $300,000. So think about that per hour. You spending 4 days on something is starting to get pretty serious money versus that $300 expenditure, right? All of these tools, ANTS, SciTech, and .trace all have trial versions. I'd encourage you to try those. Okay. It's gotten a lot better. Some of the older versions, they've improved the UI dramatically. Okay, so give it another shot. I highly recommend it. And do we have any tools for remote profiling? No. The only thing you can do is get a mini dump. Okay, and how do you get a mini dump off a production server? Well, that's simple enough. Go to systemterminals.com, which many of you already know and love. And at systemterminals.com, you're going to use a tool called ProcDump, and this is the easiest way to get a mini dump off a production server. And ProcDump's got all sorts of interesting options, like watch this memory counter, watch this performance counter if the CPU spikes. So ProcDump is really the tool. So you're going to grab that mini dump, and then you can look at it with Debugging SOS. We have classes training on that at Wintellect that I do. Also, you can look at it with the SciTech tool. Okay, so great questions. So we've had this run, and let's get back to the SciTech tool. So the idea with the SciTech tool, it's a little more invasive. So what you do is that you take snapshots, right, of the heap, and that's what I've done here. Is I just took a snapshot, and then you compare before and after scenarios. So what you can do here is, they have an API you can run with this and everything. So let's go take a look at Animated Algorithm 2. I will pick the bubble sort and sort through this guy. Let that run, let it sit for a second, and make sure everything's done. Any garbage collections that would occur would happen. And let's go take another snapshot. Now, before we look at anything, right, based on this UI, what type of memory would you expect to be the most used? Okay. Well, the thing that's neat about the SciTech tool is the delta column here. Okay. And so what we're doing is that we're comparing those two snapshots I took. And if we look at what's changed between them, right, you kind of see something funny. Is that what you expected, to see this GC handle and a weak reference, and there's over 20,000 of them? Well, that's not what I expected to see. I would have expected to see some, potentially a graphics or something like that. So this is kind of surprising, right? And, this is kind of what you look for when you're looking for kind of memory problems, right? We do the run, we pump in 100,000 items, we take the snapshot, we compare the before and after. Then we kind of see what it is, say, well, wait a minute, we see this kind of change. Okay, let's rerun it. Now let's pump in 200,000 items. Do we see a difference? And and then we pump in 300,000, 400,000, and you look to see if you're getting a linear growth. But you also look to see what type of memory it is that you're looking for. And, I'm kind of surprised here that of all of my memory, the biggest thing are two odd things that I would have never guessed, okay? So what is a GC handle? A GC handle is a special type down in the garbage collected system. When you p-invoke to a Windows API, what they do is they hold on to the memory reference for you. Because what can happen, if you pass .NET memory over to native code, that native code could cache it, then you lose the reference. What could happen? That memory gets garbage collected, but the native code has cached it. Now you've got some serious problems. So, ouch, we're hurting. So GC handles a very common thing. I kind of expect that. This is an application that is talking to the Windows GUI, the Windows UI, device context, brushes, all of that. So that's not too surprising. The weak reference, though, what the heck is that? So the trick here is here's a big takeaway. If you ever run your app and you see weak references are really big, you got a caching problem. Because whenever you see the term weak reference, that's where you look, where you see something related to a cache. So what is a weak reference? A weak reference, a strong reference, is what you write in your code. Var x equals new object. That's a strong reference, okay? A weak reference is a special thing in the garbage collector that allows applications to observe a piece of memory through the garbage collected system and allow it to be garbage collected. And weak references get used in caches, okay? So anytime you see a weak reference, you're probably dealing with something with a cache, right? So now that you know that, let's go look at the second tab here by a particular type. And this is where the SciTech.NET Memory Tool is awesome. Because I double-click here, and this shows me all my instances of that weak reference type. I can go look at all the other types here, but that's the one I'm narrowing down on. And the neat thing about this tool is it sits down here, and it shows you the most common call path into that. So what we've got here is go to function. Oops, I went to the wrong thing. Let me open up this project here, and we'll look at this code. File, close solution, Control-Shift-O. Let's open up our solution. And the method here is update single fixed element. Okay, update single fixed element. It's telling us this is the call path to what's going on. So let's look at this code and what's wrong with it? Right? Code looks pretty reasonable, doesn't it? Right? Well, it's going to update one of the bars. So it creates a graphic, it draws part of the bar with, the length of the bar, then it fills it with the background color, and then, we're done. So this looks pretty reasonable, okay? So if I just handed you this code, it would look fine. But let's go back and look at what the SciTech tool is telling us. It's telling us all of these weak references come out of that update single fixed element, okay? And the thing that the SciTech tool does very well, yeah, it should be in a using block, right? You're correct. Okay, there's a couple of things here. We've got the using block here. I could have done a using block here as well. Okay, but let's dig a little deeper because the SciTech tool is like the ultimate memory X-ray machine. The Redgate tool is as well. So this is kind of interesting because we see the update single fixed element called most commonly the solid brush constructor, which calls the system color tracker.add, which is what's allocating all these weak references. Does everybody see how that fit together? So let's go look at reflector. Okay. And let's go dig into the solid brush constructor. And here's our solid brush constructor, and the one I used was that one right there. And so there's the code for it, right, with reflector. So sure, there it is, and it's called systemcolortracker.add. Well, there's the systemcolortracker.add. Let's go look at that. So what's my bug? Let's look at that for a second. Well, this is really sneaky, okay? So let's go back and look at the code, okay? So what did I do here? Well, I created graphics and I created solid brush, okay? Well, that solid brush constructor eventually calls down to this add, and what happens here? Well, there's our weak reference, okay? So that explains our allocation, but why would they be doing this allocation? Okay. Oh, yeah, I don't need a lock there. It's single-threaded, so we can get away with it. Do you see what the problem is? Well, let's go back and look at our application. Let's think about this for a minute. What can happen during my application's run? The user can change the background color, right? Right, perfectly fine. Go to System Settings, go change it to hot pink. Well, why is this code doing this work here? Well, it's that highlighted line right there. So what happened here is that I wrote the code originally. It seems perfectly reasonable. Hey, I need a background color. Let me go get it and use it. I'm using it in the using statement, so it creates it and disposes of it. But what was the framework class library trying to do for me? They were trying to help me out because they wanted to cache these brushes so that by putting this user event preference chain, this event handler on it, they were going to get the notification when the background color changed and automatically fix up my brush for me. So what did I do here? I misused the hell out of the framework class library. So the framework class library is trying to help me out, and I actually slowed myself down, okay? So what's the fix to this? Well, don't do this. Just have one solid brush and then reuse it, okay? Very much like what we saw with Paraffin. But the fact that we go all the way into this combined view where all the weak references are and they show all the most common instances, this is absolutely fantastic. And, you know, it's so many times that it's turned out to be things like this where somebody's trying to help you out that you misuse it because it's easy to do and you cause a slowdown. And if I sit down and I run and I run the fixed version, on average it's 27% faster. Okay? Because the garbage collector has to do all that more work. So, this combined call stack thing is very nice. The Redgate tool gives you that as well. Now, if you're looking at individual types, you can look at that, and that'll look at the instance detail, shows you the reference chain right there. Right there's our weak reference chain for whichever one I picked. We can just generally look at call stacks to see how live instances, very much like the Visual Studio tool. Okay. Shreng, should it be removed? That's a good point. Let's go back and look at Reflector here. Should it be removed? Well, no. It shouldn't be. It shouldn't be removed here because they're setting it up here to handle it later, and they only add it once here. So what they're doing, if we go look at this guy here, then they say, wait a minute, has the color been changed? Then they enumerate the color changed, and then they go through and update all the brushes. If I dig through here, you'll find the code. And so they only need to set it the one time, and it works out. And so it works out. But they didn't need to remove it each time. Okay. But being able to look at all of your objects and all of this memory view is very powerful. Okay. Harvard, it's a really neat thing. It's very much like the case with the Paraffin I showed you. The garbage collector does less work. Okay, so it's two things. Allocations are very fast in .NET. It's a pointer move. Where is the pain of memory management in .NET? Deallocating. So by having the garbage collector run less, we save a lot of performance. Okay, so it's the cleanup that we get the performance boost on. Because when we look at it originally, right, we've got all of these weak references here that we've got to clean up. And if you run over and over and over, you'll see, that they just grow and grow and grow. They eventually get cleaned up. But there's extra work. There's extra promotions between generation 0 and generation 1. So, this is, it's the cleanup that you're trying to avoid, right? Long-lived objects are not bad. Big numbers of long-lived objects that you didn't expect to be long-lived objects, that's where the pain is. And so it's avoiding deallocation is what you're after. Okay? Yeah, that's one way to solve it, but, that's not a substantial issue because, if you have bad performance, what George is talking about there is you can turn a web application and okay, there's the rest of the question. Yes, okay. This is a thing you can do in an applications config file because there's two types of memory allocations that work in Windows Forms Console and WPF applications. For those of you using ASP.NET, WCF, you've only got one type of allocation. But for the general UI type allocations, there's two types. The first type is workstation heaps. That is one heap that all CPUs share. So I've got a machine here with a whole bunch of CPUs on it. Okay, great little laptop. It's an Apple. It's great. But I've got 8 CPUs. So if I run a normal Windows Form or WPF application, I've got one heap that 8 CPUs are sharing. So they trade synchronization, space for synchronization. Server heaps, what George was talking about there, turning that on if it's still there. What you would see here, if you turn on GC server equal true, that server heaps is one heap per CPU. So your overall memory usage goes up, but you avoid the synchronization. In the big scheme of things, the only time I've seen a perf boost when that happens is in very, very controlled situations. I worked on a project that was a medical machine monitoring software that was a very interesting piece of software, and the data it generated for it was a positronic emission tomography scanners. Its raw data was well over a gigabyte for an individual image, and they had an 8 CPU system. And the problem is that it was a Windows Forms app that was processing this data, so they were having synchronization problems. All we did is, since each thread was processing a band of the data, we turned on GC server equal true. We improved performance by hundreds of orders of magnitude because we avoided synchronization. But in the general case, it's not going to give you any performance boost. Okay. Yes, you're exactly right, David. What we would see is that the weak references would drop to almost nothing because the weak references are all coming from this call stack right here. And by avoiding that, we would still have weak references because there's other things that rely on them, but we've just avoided a whole bunch of allocation that misusing the framework class library solved. Okay, so good point. Is there a particular case where calling gc.collect is useful? First, I want to say no, except, okay? Do not call gc.collect. That's not going to fix anything. In fact, it's going to decrease your performance. Because when you call gc.collect, that resets self-tuning. Okay? This is very important with the garbage collector. This garbage collector is amazing. The version of .NET that you're using right now is .NET 4.5. That is actually the 7th version of .NET written. They wrote 3 versions of the .NET runtime and threw it out because they found better ways to do things. The one piece that is original, of the original team that wrote .NET that's still active today, is the garbage collector. Nobody's been able to write a faster one. So this garbage collector code is really good, and what it does is it says, oh, wait a minute, you're doing a lot of short-term allocations. I'm going to increase the size of Gen 0. And it goes, oh, okay, wait a minute, you're going to increase the size of Gen 0. Wait a minute, that's great, now we're running faster. The instant you call gc.collect, it resets. The garbage collector also self-tunes if you're doing a lot of longer-lived objects. They shrink Gen 0. So, and the same goes for Gen 1. So by calling gc.collect, you lose the self-tuning that produces much faster garbage collection, right? So, but the one case where I found that gc.collect makes a difference is a friend of mine was writing a game, and he went from level 1 to level 2. And they used none of the level 1 sprites and widgets and stuff. He called gc.collect between moving from level 1 to level 2, and he got a perf boost. But forget I just said that. For 99% of you, it will never make a difference whatsoever to do that. Okay? So back to the SciTech tool. The fact that we can dig into memory very easily, the fact that we can look at those production dumps by importing a mini dump is a godsend. The last thing I want to mention here is this view right here. It's the real-time view. I have done tremendous amounts of performance tuning just watching this view. And just looking at total bytes is pretty fascinating, because what you're seeing is that, you can look for individual types here, but what we're looking at is my runs of the application as it runs. And if you look closely here, you look at the top and you can see something very interesting. You can see the garbage collections kick in. Okay? And so you can see live. Now, when I took the snapshots, that's what produced these two Gen 2 collections. But as the application runs, okay, let's zoom out here. Okay? As the application runs, we can now start comparing, what happens when I do different sorts. Right? So we saw that the memory went up for the bubble sort there, but we can compare that to something like a quick sort, right? Okay. Which one uses less memory, right? So you can see here what happened is there's that little spot in the middle is where I paused, but you can see it barely went up when I did the quick sort. So this view here is so fascinating because I literally just watch my app run, and I just watch the total memory usage, and I watch the garbage collections. So I say, okay, we're running it. Let's go pump in 300,000 items. Okay, that's kind of the pattern we see. Yeah, cool, looks fine. We pump in 400,000. We pump in 500. Oh my God, we pumped in 500,000, and it does the hockey stick. It goes up exponentially instead of linearly, right? Well, what changed in there? And, there's a nice little API where you can put comments in here so you can get notified, doing this, doing that. And it's just a really unique view. And when I bought the version 1.0 of the tool, it was literally for this view right here, because it was just kind of fascinating to look at your memory usage intersected with the garbage collections as they ran. So I thought it was kind of fascinating. Okay? Why not use perfmon? Well, that's a good point. Perfmon will tell you the same thing, but perfmon doesn't show you this information here, Brandon. It doesn't show you when the garbage collections occur. You can guess a garbage collection occurred, but it doesn't show you which generation got collected. So that's why I kind of like to use this tool to say, well, we pump in 100,000. If we have consistent traffic of 100,000 items per second, right? We kind of see this, kind of see this, kind of see this pattern. But then we pump in 500,000 items, then we see a different pattern. Well, wait a minute, what's changing? Because we see more Gen 2 collections. Well, I kind of need to know that. So that's the one benefit. But perfmon is a perfectly fine tool, and it's free. So you can look at almost all of the same stuff here with perfmon built into your machine, right? Just go into the performance monitor, go in here, and what are you going to do? Oops, you're going to look at, wrong thing, .NET memory. And that will tell you more than you ever wanted to know about your .NET memory for an individual process. And I encourage you to have your network operations guys running with this all the time, because this is just going to tell you that overall performance of your memory on production servers or big test servers. By the way, if one of you wanted to make a lot of money, write a better performance monitor. This thing blows. Don't. Okay. Yeah, it's similar to gc.collect. Don't trust the garbage collector. Okay, Pavan, because by you trying to get smart with it, that's where you're going to have problems with it. Every time we've gone in on a consulting job and found that somebody was trying to play games with the garbage collector, with resurrected memory, with gc.collect, they actually introduce performance problems. So my rule of thumb is no, just let the garbage collector do its work, because if you start playing games with things, it gets really bad very quickly. And, so don't rely on, just let the garbage collector do its work. But it's your use of the garbage collector you want to monitor, right? And we've seen two examples here where it was overuse of things that was causing the problems. And so through this session here, I hope I was able to show you, some ideas on what you can go back to the office and sit down and do, so to look for your problems, because all the problems come in deallocation with this stuff. So, I hope you found this session useful. Right? I'll stick around until all the questions are done. I do want to flip back to the slides here real quick, because I do want to remind everybody, if you have any questions after this session, or you want to follow me on Twitter, because I'm the greatest Twitterer in the world, you can get it there at John Wintellect, and I'd love to have you follow me. And sometimes I say non-technical things too, but it's never about politics, religion, or sports, because I'm a consultant, and those are the three things you never talk about as a consultant. As a consultant, it's safe enough to talk about the weather and the traffic where you're at.
Indeed it is. Indeed it is.
So yeah, let's open it up to any questions. It's been great, the questions through the session. I really appreciate those. I know we've gone a little long, but who cares? They've been good questions.
Well, that's absolutely fine, John. Brian's had to leave, so I'm taking over.
Okay.
If you've got any more questions, guys, let's put them in. There's a couple for you, John.
Okay. Udi, you are exactly right. There are trade-offs with everything that you do. And the cases I was showing, were kind of single-threaded, but they show the very common patterns that we see over and over and over. But you're absolutely right that there is, if you're in multi-threaded environments, you're going to have to think about it. Right? If I make this a static, what is the ramifications of that being static on the rest of the system? And by, and I've had cases where I said, okay, well, let's try to make this static, putting the protection around it, and the performance gets massively worse because we're spending all our time blocking, which means a transition to kernel mode, so we do less work. So, yeah, there's definitely a trade-off here, and I didn't mean to downplay that at all. And so I really, really appreciate you bringing this up. Okay? Well, we cover a ton more. We go much deeper into the Visual Studio tools, go much deeper into the SciTech tools. We do look at production-type problems, so it's much deeper. But we also spend time talking about the more about the infrastructure, right? What's going on with the garbage collector, so that you can get a better idea of who's doing what to whom. And so, by understanding the architecture of Windows, we also spend a lot of time, looking at small performance, what we call the performance of everyday things. So that how do I sit down and figure out, is a for each better than the for loop? Why? And things like that. So not that we can do macro, we don't hit Donald Knuth's, premature optimization is the root of all evil, but the idea is more that we sit down and figure out, excuse me, where some of those very common small things as you're doing your day-to-day coding, because those things make a lot of difference. Patrick, the JavaScript performance analysis in Visual Studio is quite good. It's very much the same UI. It's the same UI, so you do the same type of operation. The JavaScript profiling tool has been everything. That's the only tool we've used at Wintellect. It's the one that's worked best for us. So it's basically just turn on JavaScript profiling and you're done. So it's very clean, very concise. Yeah, we're kind of, we've been having a lot, just a little aside, we do nothing but websites now for consulting work. All right, websites are everything, and JavaScript is everything now. And we've been having a lot of discussions inside Wintellect about TypeScript. We really like that approach. So I've been looking at TypeScript quite a bit, and it's a real neat thing. Okay. So cool.
Yeah,
Any other questions?
There's been a lot of talk about TypeScript lately.
Yeah.
Sorry, go on.
Well, it brings, we've had a lot of problems, like a lot of folks, when you start talking about big team development with, a lot of stuff happening in the browser, right, what users expect. And, how do you define an interface, right? How do you define, things that, there's a looseness with JavaScript, which is part of its strength. But it's not a double-edged sword, it's a double-edged atom bomb. And that's where, if it's a three-person team and you can spin your chair around and talk to the other person and get it coordinated, that's fine. But when you start getting into real big line of business applications, we have 20, 30, 50 people in a big team working on a big suite of applications. JavaScript has some problems. And that's what customers are.
I can believe that.
Yeah.
Well, I'll tell you what we're going to do here, John. I'm going to wrap the actual presentation up itself so we can switch the recording off.
Okay.
So thank you to everybody who's attended. I believe Brian had that wallpaper around here somewhere. I can't quite remember where it is. But as he said, we've celebrated our 50,000th member, and that's only in the last 2.5 years, and we'd like to keep on going the way we are. We'd like to think that we're still going to be doing these presentations with people like John in 2.5 years from now, with maybe 100,000 users. Thank you everybody who attends and all of our great presenters who made it such a success so far, and I trust John will come back in a heartbeat without any problems. And that's a wrap for tonight. Just